Hey guys, it's Jair, and I'm going to be introducing Samaritan's new production-ready features. So we're going to be covering logging, events, and the all-new dependency injection framework. So let's get started by creating a new project. Let's call it example. And I'm going to go ahead and make a new package and a new main class with a method. Whoop. Okay, so first step, let's just import the library to the build path. You can do it just like this, and you can see this little symbol there that indicates that it is part of the build path. So I'm just going to cover logging, right? Logging is a new feature in production Samaritan, and it's just there for show right now, right? It's there to mark a concept. It's there to mark the beginning of a new journey, right? Like something that's bound to be completed later. And I admit it doesn't have all the features that I want it to have. I want it to have a lot more features. But as of now, we just have a working production ready copy that you guys can use by example. So in order to get a logger, we're going to need a logger instance. We're going to use logging.logger. And this same fashion with the utility classes like this is throughout the production ready Samaritan library. Again, it's production ready means it's minimalistic, it's fast, it's efficient, the code is minimal, you know, everything is put together nicely for you and it's ready to use. It's ready to use in production. And that's what the goal is. The beta Samaritan is really sloppy and you would be a fool to use that in production. This is ready for production. It's without documentation as of now, but it is ready for production use. Okay? So with our logger, we get the typical features that you get. You have the different levels. It's a level-based logger. You have the different levels. So you have debug, you have error, you have info, and all the way down here we have warning. And you can pass in, the output that you want. And notice that it accepts an object. It doesn't accept a string. That's important because you can go ahead and say you want to do info. You can pass in, you can pass in this, you can pass in hexy, you can pass in binary, you can pass in whatever you want with an object. You can even pass in another logger in there. But for our example, let's just go ahead and do hello world, quick hello world. So we can just run it, show you guys simple, trivial example works. We can also use the set level feature to say disable all the logging in the system. We can use set level, and we can use level.off, which is I'll show you guys a list of the levels right now. We have all, which means that everything's going to be outputted. Debug, error, info, warning, and then off. Off means that nothing is logged. So as before, when we ran with we ran it and we got hello world. Now when we run it, we get nothing. Okay? So that's, it's pretty straightforward. The logging library is straightforward and easy to pick up. And of course, I want more features. I want timestamps. I want changing the output location. I want all these features, but I need to get them production ready to actually release to you guys. So let's just go ahead and comment this out. And I'm going to introduce you guys to the event system next. So if you're familiar with the common event bus architecture that Google introduced in like 2009, 8, sometime, I think 2009, in Google Guava, their event bus it set the standard for event systems inside your application. It's lightweight, it's fast, and it's ridiculously easy. It's versatile and ridiculously easy to use. It just has so many use cases, and not using one is just, you'd be silly to not use an event system inside your library, especially if it's non-trivial. Okay, so Samaritan provides that. I know that you guys want an event. You guys want an event system. You want the event bus system. So what I did is I wrote an event bus system that is so fast and so much faster than Google's solution and other people's solutions. It only uses 2 expensive operations per dispatch. I wrote it with performance in mind. Like, you're going to get top performance out of this library during your application runtime. I know, like, for example, in Bucket, my contribution to Bucket way back in the day, that was, equally split between registration speed and post speed. In Samaritan production, it's all about the post speed. I care nothing about registration speed. Actually, registration is quite slow. But what you get is, what are you doing more, right? Are you registering your listeners, or are you posting a zillion events per second, right? In a game server, web server, anything like that, you are going to be almost always posting more, right? So you might have, 10 milliseconds extra on your startup time, but you're going to save significant time inside your actual application running. So that was my goal for this. So let's introduce you guys to it. So we need an event manager, which you can retrieve in the same fashion as login.logger. We can use event.manager. Right? So now with our manager, we can both post events and register event listeners. Now the cool part about Samaritan's event system is that it's very easy to create event types. So I'll just go ahead and make one. We'll just call it, for reference, example event. Alright, so let me show you guys how easy it is to make this into an event. That's it. That's it. You need to implement the interface event that has no requirements here. You see, it's very, very, very simple here. There's nothing complicated here. You just implement event, and wha-bam, you have an event type. You can do this on enums. You can do this anywhere, right? You can implement an interface pretty much anywhere. That's why I did it, right? And note that you can't post an object like Google's library. You have to post an event, because people can screw over other people's libraries by using this event system, right? You can mess with other people's code with Google's library. You can't do it with this. This is very flattened out. So we're going to post an example event, and now we're going to want to register a event listener. So I'm going to show you guys how simple it is to make one of those. So I'll just call it example event listener. So again, same steps. Oops. You just need to implement event listener, and wha-bam, you have an event listener just like that. So again, very easy to implement, very quick, you don't really need much structural integrity. And again, over here we can register that. So just like that, we have our system set up in the main class. So now I'm going to go through how to set up a stub or subscription stub. You need to create a public method. Doesn't matter the return type. You can, of course, you can use this subscription stub as a regular method. It is a regular method. I'll just call it on example, because that's the typical convention, calling on whatever. And we're going to be accepting an example event. I'll call it event. And just in this example, I'll just go ahead and do a hello world in sysera. And to finally top it off, you need to mark this subscription stub with add subscription. Oh, add subscribe, sorry. Which tells the library that, hey, this is a subscription stub, right? It's called this, and it wants an example event. So we're going to pass it in there. And we get to use all the properties of the example event type. Okay, I'll show you guys that in a second. So just for this example, we can run it, and we get hello world just as we expect. But I'm going to show you guys how to you can further improve this, right? So instead of example event being, plain, what if we let you pass in the message in here, right? So we can go ahead and make it like a string here, message, and making a constructor for this, and we can make, I don't know, generate a getter for it. Okay, so now over here we have to pass in what we want to say. Let's say hello world. 2 exclamation points to see the difference. And now instead of here, we're gonna pass in event dot, guess what, message. We can use it just like the regular type, right? Now when we run it, we get the same result with 2 exclamation points because, voila, we are passing in a custom message. Okay, so Now let's get on to the meat and potatoes, right? Let's get rid of this. And let's get out the big boy of the libraries. That's the dependency injection. That's where Samaritan really shines, right? This is the all new groundbreaking stuff here, right? So say I want to replicate the behavior found here, right? I want to replicate the event manager with these types, right? So we need an event manager somehow. How do we get one, right? That's our question. How do we get it? What do we put here, right? Well, we're going to start off with an injector. And in the same fashion as everything else, again, it's just like this. Dependency injection dot create injector. So, injector gives you crazy features, right? Let's check it out. You get your instance of, which constructs an instance of whatever type. You get your instance of a key, which is a special type made for Samaritan's library. And you also have the underlying access to the binder of injector, which is great. I mean, if you want to mess around with the internals, I give you an SPI to mess around with it. So in our case, we're just going to do instance of, and we want, of course, event manager. And voila, we have replicated the behavior. So, to complete our thing, we're going to have to pass in an event module. Event module. And I'm going to open this up to show you guys it. So what we're doing in here is, this is an abstract module. I'll get to this later when we're creating our own module. We're binding event manager to the default event manager. And you can make the default event manager yourself, right? You can do new whatever, right? But it's not automated. You don't get the automated parameter filling. You don't get the automated construction. That's the use, right? You can do dependency injection without a framework, but it gets really messy, really fast. So that's what Samaritan is made to do. So if we run it, we have the same behavior. We have replicated the behavior of this whole stuff, with the use of an injector. So let's say we want to make things a little more complicated, right? Because complicated stuff is better. So let's say in our example event listener, instead of using syserror, we want to use a logger, right? A Samaritan logger in here. So if we're doing normal dependency injection, we would just make a field called logger and make a constructor for the logger. So we want our logger, and we want our constructor to set the logger. Okay, and now we'll convert this to use logger. I'll just do info. So voila, we have our constructor here, right? One problem: in the main method, we are now lacking the value. So I'll just show, for example, we can just pass in logger not logger in here, right? And again, we have the same behavior here. It's just the same thing. But let's say that we didn't want to do this, right? So what can we do? We can make a logging module, right? We can add a logging module, which is also included in Samaritan. And then we can construct a logger in here. Or we can go a step further, right? We can go a step further and make a custom module for an example event listener. So that's where things get really interesting. So to signify that this method should be injected in, we're going to use @inject, the annotation over it. And that says, hey, to the library. The library's like, hey, we need a logger in here, right? So we need to figure out how to create that logger and pass it in there as a parameter. And @inject just means that, hey, this is the constructor that we want to use. So say we had another constructor in here, you know. So we just had another constructor in here where we would just pass in logging.logger. Just like that. This is to just differentiate between the two. @inject says that, hey, this is the one we want to use. So get rid of that. Okay, so now we can come back into main method and we can generate this ourselves. Vector.instance of, and we want an example event listener in here. And just like that, we have our injector generating the class. Now what we need to do is we need to set up a module to specify how this thing is getting constructed, right? So I'm going to make a new class called example module. And in the example module, we're going to extend, or actually, I'll show you guys two ways. This is cool. So the first thing you can do is something interesting. You can now use a regular module with all the synthetic sugar that you get with an abstract module. This is something really new. Like, I've never seen a library do this. And of course, if you guys know any library that lets you do this, please link it in the comments. I'm always interested if anyone has any cool libraries for me to see. But right here, we have our binder, right? Pass it in the binder. And we can use the synthetic sugar methods here. Notice this. The internals of the library are built with synthetic sugar. I've never seen that before. That's why I'm introducing the library to you guys again like this. So we can go ahead in here, right? We can do the whole we can do example event listener to self. And just so you guys know, to be clear, to self is a feature which doesn't require you to do this. It's just a shortened way to do that. Like this top, in Google Juice, you have to do this. You have to do this. You have to repeat. In this library, you can do to self. You can say, okay, just bind it to yourself. So that's pretty cool. Like, it works the same way. And what's cool about modules is that modules an interface. You can implement it anywhere you want. This is the only requirement. It's actually a functional interface too. If you guys are interested, you can pass functional interface into the into your create injector method, which is, again, that's something sick, right? Java 8 with functional interfaces. This is one. This is a functional interface right here. You have that flexibility. That's crazy flexibility you have right there. Or you can do the old-fashioned route, which I'll show you guys. Oops. The more simple route, which is to use abstract module. And the only thing that changes is you no longer have access to the low-level binder. You now are using synthetic sugar to do your bindings, which it's more readable. Like, you have the choices. You have the other one, which gives you more flexibility. You can do the internal mods. You can use it as a functional interface. And then you also have abstract module, which is more readable. It's easier to understand. It's simpler. It's a simple version, and it makes sense to people who are reading your code. You can see that, hey, we're binding an example event listener to itself. That's all we're doing. So now back to the main method. To complete this off, we're going to create new example module in here, and that's our job. And our job well done. We have the same result as before. We are just doing it with dependency injection. Automated dependency injection is doing everything for us, right? So I'm going to show you guys another cool feature that we have, right? Which are constant bindings. So say you don't want to pass in this whole hello world, right? Say you wanted to make that a constant. So I'm going to make an annotation called hello. This annotation has no value. So this is something you guys need to learn. You need to set the retention policy to runtime. And you can set the target up however you want. I typically like parameter for the target. Okay, so when we're constructing our example event, let's turn this into automated dependency injection, right? Instead of using hello world here, we're going to make that a constant. We're going to do that. So in here, we're going to change this up. We're going to add inject straight off the bat. And now for a message, we're going to add hello. Add hello. To mark that, hey, this is a constant that we want to fulfill. So the library is going to look at it and say, okay, where's our constructor we want to use? Here it is, because it's marked by inject. And what do we need to pass into that constructor? Well, we need a string, right? And where do we get that string? Well, it's marked by hello, which means that the annotation marks a constant. So now we got to go back to our example module, and we can bind this constant. So in the same fashion, we're going to bind hello world and let's do it with 3 exclamation points this time, to our annotation. Hello.class. And you guys can see that the library will only give you the options to do what you want to do, right? Like, you can't make a mistake. See, there's no other options here. That's a void. The 2 is a void. It's done. You're done. The operation's done. You can't do any more. In this, into self, you see we have another operation. We have more operations here. It's just something to think about, right? So, with this, like, that's pretty much all we have to do. Now over here, instead of doing it like that, we can do injector. Let's create an instance of a example event. Oops. Oops. Oh yeah, I remember what's wrong. I was like looking around here. I'm just like, what's wrong? Okay, we have to, as well as doing the instance, we have to also bind the example event to itself. So voila. Now we can finally do it. I'm sorry for that, guys. Sometimes I forget. So now not only do we have a binding from hello world to hello, we also have bound example event to self, just like the same case with example event listener. So now I'm going to talk about scopes, right? It's kind of wasteful every time that you're constructing an example event to be, using a different event type, right? Scopes lets you do that. With scopes, you can do in scopes.singleton. Now we can say, okay, let's go inside the singleton scope, right? So singleton, if you guys know what a real singleton is, it means that that's the only instance that you're going to get. So throughout everywhere where you want an example event, you're going to get the same instance. It's going to be constructed once, cached, and it's going to be returned the same time, right? So now our example event, no matter where it is, it's going to be the same. So if we run it, it's going to be the same result. But let's say this guy, he wants an example event for some reason, right? I'll just show it for example. He wants an example event now. I don't know why, but he does. And we're going to just check for non-null of it. So when we run it, you see that, yeah, it's non-null. We're getting the same event. So actually, I'll show you guys something cool. If we print this out, we're going to have the signature of that instance, which is, this is the signature, I guess is the memory address or something that's there. We're going to take that signature and we're going to put it over here and get the same, check the signatures here. You guys can see, we're running the same instance. It's the same instance that's getting passed around. By doing in singleton, it's going to be the same instance every time. And that's why, for example, if we look inside event module, you'll notice that event manager is bound to default event manager inside the singleton scope. So yeah, when you're passing around it, you're getting the same instance every single time. And it's quite useful, to be honest. So, that's pretty much it, guys. Like, you can, I know, like, you guys are probably thinking about all the uses that you can do with the framework, but as of now, like, it's pretty much, the meat and potatoes of what you want in a dependency injection framework. I mean, it's no Google Juice. I don't have that many features. It's not that in-depth, but it's very straightforward, and it's very easy for you to use, right? It's very simple for you to use and comprehend. So thank you guys for watching, and subscribe, do whatever, and make sure to follow the Samaritan library on GitHub. And again, thank you guys. See you.